Okay, let's just review all students take calculus. So here is my coordinate axes, and here is ASTC. So everybody's positive here. Sine and cosecant are positive in the second quadrant. Tangent and cotangent are positive in the third quadrant. Cosine and secant are positive in the fourth quadrant. So if we know that this angle is pi and this one is 2 pi, and all angles are start in the standard position where angle is starting at 0. So we want it to be right over here where this is our reference angle. So the question is, how do we get an angle that starts in standard position and ends at this terminal side here? Well, if we want it to be just short of pi, it'll be pi minus our reference angle. If I want to get a third quadrant angle, my reference angle is here. Notice it's done with respect to the x-axis, just like this one was done with respect to the x-axis. This angle is a little past pi, so in order to get an angle that starts, let me get a different color, in standard position like all angles, and rotates counterclockwise and ends right here. In order to get an angle there, you do pi plus your reference angle. And finally, if we want a fourth quadrant angle, we draw our reference angle, which is done with respect to the positive x-axis. In this case, this was done in terms of the negative x-axis. And if we have an angle that's in standard position that rotates counterclockwise, an angle that lands in the fourth quadrant is going to be done with respect to 2 pi, or the positive x-axis. So it'll be 2 pi minus our reference angle. So we're going to do these two in terms of pi, and then we'll do it in terms of using your calculator, so we can extend it to other problems. Notice we have sine of theta is equal to 0.5, so we should all say in our heads that the sine of theta is equal to 1/2. So our reference angle in one of our solutions is pi over 6. However, we want the second quadrant angle because this is the S quadrant where sine is positive. So our second quadrant angle is going to be pi minus our reference angle, which is pi minus pi over 6. And we should all know that that is 5 pi over 6. So there's our two answers. Okay, so here's our 4 quadrants again with our handy dandy for getting angles in the applicable quadrants. And here we have sine is equal to -1/2. Again, whenever I do this problem, I ignore the negative. I say when is sine equal to 1/2, or that's equal to our reference angle is going to be pi over 6. Since we want sine to be negative, we're going to want to be in the third and the fourth quadrant. So in that case, it's going to be pi plus our reference angle and 2 pi minus my reference angle, which is equal to pi plus pi over 6, which is 7 pi over 6, and 2 pi minus pi over 6, which is 11 pi over 6. So let's look at these same problems, but doing it decimally. So again, here's our unit circle, and all students take calculus. Let's just remember, so I'm in radian mode. We're in pre-calc here, we're not in physics. So if you recall, we just did this in terms of pi. Our two answers were pi over 6, and 5 pi over 6. So those are our two answers, decimally speaking. So we're going to do this problem decimally using the graphing calculator. We're going to imagine that this value here is not one of our classic trig values. So therefore we can verify that if we do it using the graphing calculator, we get the same solution. So I'll write these two answers down here, and then we'll do it using the graphing calculator, and then hopefully we'll get the same answer. So you notice I have the two answers written right over here. Now let's do it using your graphing calculator. So in order to handle this, the first thing I need to do is take the inverse sine of both sides. So these two are inverses of each other, so they'll cancel out. So I get theta is equal to the inverse sine of 0.5, which will give me the first quadrant angle. So using the calculator, we do second sine of 0.5. Don't need closing parentheses. I get 0.5235987756, which is the same I have over here. So I'm just going to write it over here, showing it's part of this solution. So sticking with our graphing calculator, it's not really necessary in this problem, but it's a good practice. So I'm going to stow it by hitting the stow button. That gives you ants in the arrow. Then I hit the X key right here. So therefore now this value is going to be stored as X, and only in this window and in your table window. If you plug in X for your table value, this will be your X value. So we want to get a second quadrant angle. So a second quadrant angle, because this is sine is positive, so sine is positive in the first. We already have that angle. And the second, which is pi minus our reference angle. So we do second pi, or second the exponent, or chevron, minus our X value is 2.61, which is the same answer we got here. So I'm just verifying that we get the same thing using the graphing calculator or doing it in terms of pi. You'll never do a trig equation where the answer is one of your classic trig values, meaning 1/2, radical 2 over 2, radical 3 over 2, 0, 1, -1, and undefined. But we're just using it so we can extend this idea to some other ones that are non-traditional unit circle values. So I'm just going to write this answer down so we can move on to the next problem. So notice that I just wrote down pi minus my reference angle, which in this case, this is my reference angle, gives me this angle right here, which is a second quadrant value. So now let's move over to sine equals -0.5, decimally speaking. So if you recall from earlier, sine is negative in the third and fourth quadrants, so they were pi over 6, my reference angle, so 7 pi over 6 and 11 pi over 6 were my two values. So let's use the graphing calculator. So if we do 7 pi over 6, we get that number. And if we do 11 pi over 6, we get that number here. So I'm just going to write those two values down here and then do it using the graphing calculator and some of the logic that I need to extend, and we'll get the same answers. So here are our answers. Again, here's my unit circle with the our 4 quadrants with all students take calculus and how you calculate angles in different quadrants. So the first thing I want to do is take the inverse sine of both sides, but I'm going to pretend this negative is not here, so you just kind of pretend the negative is not there. Bye-bye. And we're just going to solve for theta, doing inverse sine of 0.5. I don't know why that extra dot is there. So just using the graphing calculator, pretty straightforward. Second sine 0.5 is our value, and I'm going to store that hitting the stow button right down here on the left, and then the X key. I could use any alpha key if I wanted to. I could do green and then any of these alpha letters here. Just alpha, I guess. Not alphanumeric. Numeric would be numerical value. So therefore, here is our reference angle. Since we want sine to be negative, we want it to be in the third and the fourth quadrant. So therefore, how do we get a third quadrant angle? So that would be our first answer would be pi plus our reference angle. And our second angle would be 2 pi minus our reference angle. So using the graphing calculator, we would do pi plus our X value that we just stored, which is the number we have here. And then I want the fourth quadrant angle, so I do 2 pi minus my reference angle, and I get that other value here. So note that I disregard the negative. I use this inverse sine, and then I just do the how do you get each quadrant angle using the x-axis as a reference point, and using the reference angles, and then finding the different values. So I'm just going to rewrite these answers over here because I feel it's official, and then we'll wrap this video up. Okay, so that's how we handle those. Now we'll move it on to ones that don't have classic trig values, unit circle values. So you have to use your graphing calculator. It's the only way you can solve it.